Today I'll talk about universal gas constant. That is, we are going to calculate R. R is universal gas constant. Now I will show you how to calculate R. Now R can be calculated from ideal gas law. So that is PV is equal to nRT. What is P? P is pressure. What is V? V is volume. What is N? Number of mole. What is R? Already know. Universal gas constant. Now what is T? T is temperature. Now here if we reorganize, so R will be PV by NT. Now at standard temperature and pressure, what is the volume, molar volume of ideal gas? So that we must remember, and from there we can easily calculate R. Now at standard temperature, and pressure, that is called STP. The molar volume of an ideal gas is defined as so we can write here molar volume at STP means at STP means we have to mention temperature and pressure. So that is 0 degree centigrade or 273.15 Kelvin, that is temperature, and pressure is 1 atmospheric pressure. What will be the molar volume? Molar volume approximately 22.414 liter per mole. Molar volume means molar volume means volume per mole, means 1 mole. What will be the volume? So molar volume at STP 0 degree centigrade or 273.15 Kelvin and 1 atmospheric pressure, that will be approximate 22.414. So we have to remember this. If we remember, we can do anything. We can calculate R in different unit. What does it mean? So this means that 1 mole of an ideal gas occupies occupies approximately 22.414 liters at standard temperature and pressure. So you know that. Now after knowing this, now we can calculate R. Okay. Now we know ideal gas law. So PV is equal to nRT. R will be PV by NT. Now P is the pressure, so that is 1 atm. And then V is the volume, we know from here, so that is molar volume at STP, so 22.414. so you can write 22.414 liter. Now N is 1 mole and T is 273.15 K. Now if we substitute all this, so R will be 1 atm, 22.414 liter by N is equal to 1 mole and T is 273.15 K. Now we'll have 22.414 by 273.15. So unit will be atm, then liter, then mole and Kelvin. So that value will be, to calculate, 22.414 divided by 273.15. That will be 0.082047758 atm, liter, mole and Kelvin. So you'll get that unit. Now so means here this is R. So R is equal to 0.082 0574447, or you can remember that 0.082 atm, liter, mole, Kelvin. Now if I change the unit, so we can also calculate R with different unit. Like here P is equal to 1 atm. So now here P is equal to, I am changing color, 1 atm. Means what? We can take 101.325 kilopascal or 101.325 Pascal, or we can take 14.696 PSIA, or we can take 760 mmHg. We can take that. Now volume here is, we can take molar volume, So that is 22.414 liter. So that we can change to meter cube. So we know 1 meter cube is equal to what? 1 meter cube is equal to 1000 liter. So here we can write, or 1 liter is equal to 0.001 meter cube. Okay, so here we can write, so 1 liter is equal to how much meter cube? 0.001 meter cube. So now if we do that, so what we will get? We'll get 22.414 into 0.001. So that will give 0.22414 meter cube. And temperature, that is 273.15 Kelvin, or that is equal to 0 degree centigrade. Now we can take that, and based on that we can calculate different unit, like again, so R is equal to PV by R NT. So now P can I choose 101.325 kilopascal. Then I can choose kilopascal. The liter I can choose, the volume I can choose. Okay, so that is liter per mole, and that is liter per mole. Or we can write liter or meter cube 0. So this is 0.02414 meter cube. N is equal to 1 mole, and T is equal to 273 Kelvin. So we can get 101.325 into 0.02414 divided by 273.15. So that will be 8.314 into 10 to the power minus 3 kPa meter cube mole Kelvin. So we can we can get different R unit by using that PV and T. Remember that. So now here we can remember, suppose this is system, then temperature, then pressure, then molar volume at common standard temperature and pressure. So if you remember, we can easily calculate what will be the R. So now SI unit, T is 273.15 Kelvin, pressure is 101.325 kilopascal, then volume is molar volume, so that is 22.414 meter cube per kg mole. That is one. Then we can take universal scientific system, universal scientific system. So that is 0 degree centigrade and 760 mm Hg and then what will be the volume, molar volume? 22.414 liters per gram mole. Okay, and then American, we can take 32 degree Fahrenheit, we can take 1 atm, and then we can take that volume will be molar volume. If we change that, 359.05 feet cube per mole, so that mole will be pound mole. You can write that per pound mole. So if you remember that, we can easily calculate what will be the unit of R, or what will be the value of R. Now here I am going to calculate that R different unit again. So now we am taking that P is equal to 760 mm Hg, and then V I am taking 359 feet cube, and then N is 1 pound mole, and then T is equal to 32 degree Fahrenheit, or we can take as a 32 plus 460, that will be ranking. So that is 492 degree ranking. Now if we take that, now here P is 760, V is 359 feet cube, N is 1 pound mole, T is 492 ranking. Now R will be, so PV by NT, so that is 760 mm Hg into V is 359 feet cube, and then N is 1 pound mole, and temperature is 492 ranking. So then if we do the calculation, we'll get different R. So that R will be 554.55 mm Hg feet cube, then pound mole, and then ranking. So that unit is different. Okay, so R is equal to 554.55 mm Hg feet cube, pound mole, and ranking. That we can calculate. Now another we can calculate here. Now we are taking P is equal to 14.7 psia, V is equal to 359 feet cube, N is equal to 1 pound mole, and T is equal to 492 ranking. If we take that value, so R will be PV by NT. So P is here 4.7 psia, V is 359 feet cube, then N is 1 pound mole, and T is 492 degree ranking. If we do the calculation, we'll get 10.72 psia feet cube, pound mole, ranking. So R will be 10.72 psia feet cube, pound mole, 0 degree ranking. So that is the value. Now that way we can easily calculate the universal gas constant. So we can change different unit, we'll get different R. So remember again, so this is vital. Okay, so these things you have to remember. If you remember this, you can easily calculate R. And corresponding, if you change the unit, corresponding unit will get different R value. So that's it. Thank you.